Okay, so now we're looking at page 45. So, page 45. So take a look there, page 45, and then we're going to do this regression here. What we're doing is the following table shows the average retail price of gasoline per liter for a selection of years in a 30-year period beginning in 1979. Okay, so that's what this graph here tells. So we're going to take this data, we're going to put it in our calculator, and we're going to figure out, using the R-squared values, which one is the best option. Okay, now a lot of times when the questions come up, it'll tell you, here's the data, it's a linear, using this linear equation, and then you go, aha, I just have to do a linear regression. If it doesn't tell you and it says find the best line of best fit or the curve of best fit, then you have to use the R-squared values to figure out which one to use. So most of the time they're going to tell you, sometimes they don't. Okay, and when you don't, then you use the R-squared. So we've got our table. We're going to use our technology. First thing we're going to do, what's the first thing we're going to do? The first thing we're going to do is we are going to make sure that our diagnostic is on. So second function 0, x to the -1, scroll down, diagnostic on. Press enter again, it says it's done, we're good to go. Okay, then we're going to clear everything. Clear everything from y equals. I know I had a bunch of stuff in there from the last question. And then we're going to clear our lists. Oh yes, so go up to the top of the list, highlight L2, hit clear, and then hit enter. Okay, go up to the top of list 1, hit clear, and then hit enter. And when we look back, they're all gone, right? Now we're going to take our data and we're going to put it in. There's a lot of putting data in, right? So, years after 1979, 0, enter, 3, enter, 8, enter, 14, enter, 26, enter. Then let's put our other information in, 21.95, enter, 43.26, enter, 47.95, enter, 54.18, enter, and 92.82, enter. Okay, it's all in there. All right, so next we check, is our stat plot on, right? So second function, stat plot, why yes it is. So enter, it is on, we're good to go. Now we want to graph that. We're going to adjust the windows, zoom, and 9. And if you're wondering what 9 is zoom stat. Okay, so 9, and there is our scatter plot. Okay, so we've got some points going up, and then one way up there. Okay, so you can sketch that into the little diagram box that's on page 45. We'll do that later. Now we have to do our regressions to figure out which one is the best, right? So, linear regression, we're going to start with that one. Stat, arrow over to calc, linear regression, it says that right there, is number 4. So, oh, let me do that again because I didn't put in my L1, L2. And I don't know how much of an impact that is, but we want to make sure we do it. So second function 1, comma, second function 2. I can actually see if it's got a big impact. Well, maybe not. So linear regression has an R2 of 0.93944. Okay, let's do the next one. Calc quadratic regression. Again, second function 1, comma, second function 2. It's thinking for quadratic, R2 is 0.941998. Okay, it's a little better than the linear. Okay, if we look at my two numbers so far, quadratic is better. So last step, we're going to do calc. So we go second function, or stat, arrow to calc, and then we want our cubic regression. which is 6. And then second function 1, comma, second function 2. It's thinking, whoa, my cubic regression, look at that, is 0.99009. So comparing those three, I think we can safely say that cubic is that line. Okay, so while we're on this screen, let's take a look at our values. I've got A is 0.01504, but it's 47, so 0.5. B is negative 0.55465. I only need 4 decimal places though. C is 6.91822. And D is 23.52783. So I have all my values and I can put them into Y to write my equation. So I'm going to round that to the 4 decimal places. So I'm going to have 0.015, and then I guess it would be a 1 because that 5 would round up. Okay, and that would be x to the 3, right, x cubed. And then plus a negative 0.0, oh, no, not 0.554, I guess it would round to 7, x squared. And then plus 6.9182 x, and then plus 23.5278, just 4 decimal places. Now we're going to graph that. Woo, look at it. Isn't it pretty? Look at how it goes through all those dots. It's this beautiful little cubic curve, okay? So you can sketch that also in your diagram, okay? And we now can use this graph to answer the questions. So on C, estimate the average price of gas in 1984 rounded to the nearest hundredth. So 1984, how many years after 1979? So 1984 minus 1979 equals 5. So our x value will be 5, right? And so let's figure that out. So second function trace value, and we'll put in a 5, and I'll get 46.14 dollars, right? Because I can round that up, okay? Or 40, yeah, okay? The next question, extrapolate the average price of gas in 2010, rounded to the nearest hundredth. Now, let's check our windows. Our windows only go up to, well, let's see, 2010 minus 1979 equals 31 years. So our X max only goes up to 28.6. So let's extend that. Let's put maybe 34 in just to open that window up, okay? And we'll graph it again. Because if we didn't, then it would give us an error message, okay? So we want to know what happens when x equals 31. So second function trace value, we put in 31, and we get 154.76, okay? Now again, depending on how you round, you might get slightly different numbers. So try and make sure that you're rounding to 4 decimal places. And I'm not sure I rounded quite correctly. I think that should actually be 15.04. So I kind of did it in a rush. So just make sure that you're rounding to the correct decimal places, okay, and following your rounding rules. Then it says, estimate the year in which the average gas price was 56 cents per liter. So what we're going to do is we have to figure out, that's the price of gas, right? 56 cents per liter. So we're going to go in here and we're going to make a y equals 56, and we're going to graph Now we get a line across, right? So then we go second function trace, and we're choosing intersect because we want to know where these two lines intersect. So the first curve, and then the second curve, and then we're going to guess where the intersection is. And it is at 17.76. Y is equal to 56. So if we add 1979 plus 17 point, I think it was like 6, right? We get 1996 point something. So 1996 is a good estimate for that value. Okay, it's not precise because it's a whole year. So sometime during that year, that's probably when the gas went up. Okay. So that was page number 47. Okay. I think for the rest of it, you should be good. If not, we might have a video to go along with it.